preparing for an Oracle DBA interview? You've reached Interview Guide, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Can you explain Oracle database architecture and what happens when a user executes a SQL statement? Oracle database architecture has two sides, the instance and the database. The instance contains memory structures like SGA and PGA, plus background processes such as DBWN, LGWR, CKPT, SMON, and PMON. The database is the physical files, data files, control files, and redo logs. When a user issues SQL, server processes use memory, update buffers, write redo first, and later persist dirty blocks to data files. That separation drives recovery behavior. While answering, focus on instance versus database, SGA, PGA, core background processes, physical files, and how a SQL request flows through memory, redo, and data files during normal operations. Question 2. What is the difference between undo and redo in Oracle? Redo protects committed changes. Undo protects transaction consistency. Redo records change vectors, so Oracle can roll forward during instance or media recovery. Undo stores before images, letting users roll back transactions and allowing readers to see a consistent version of data. In a commit, LGWR flushes redo before success is returned. Undo may remain for read consistency based on retention, but redo is the foundation for recovery. Make sure to cover redo as recovery information, undo as before image data, commit behavior, rollback, read consistency, undo retention, archived redo logs, and why both are required. Question 3. What happens during instance recovery after an Oracle database crash? After a crash, Oracle starts with the control file and online redo logs to find the last checkpoint. It rolls forward changes from redo, so data files include committed and uncommitted changes that were in memory. Then it rolls back uncommitted transactions using undo. SMON coordinates this automatically during startup. The key point is write-ahead logging. Redo makes committed work durable, even if DBWN had not written the blocks yet. In your answer, talk about checkpoints, SCNs, online redo logs, roll forward, roll back using undo, SMON, committed versus uncommitted changes, and why recovery is automatic after startup. Question 4. How would you design an RMAN backup and recovery strategy for a production Oracle database? I prefer RMAN because it understands Oracle block structure and recovery metadata. A solid strategy includes weekly level 0 backups, daily incremental level 1 backups, archived redo backups, control file auto backup, and regular restore testing. For point-in-time recovery, I restore the right backup, apply archived redo until the target time, and open with reset logs when required. Backups are only valuable if recovery time and recovery point objectives are proven. Be sure to mention RMAN catalog or control file metadata, full and incremental backups, archived redo, control file auto backup, retention policy, restore testing, and point-in-time recovery steps. Question 5. How does Oracle DataGuard work, and when would you use it? DataGuard maintains a synchronized standby database for disaster recovery. The primary ships redo to the standby, where it is applied using managed recovery. In physical standby, the block structure is identical. In logical standby, SQL apply allows some reporting flexibility. Protection modes trade performance for data loss tolerance. I also mention broker, switchover for planned maintenance, failover for disasters, and monitoring apply lag closely. While answering, cover primary and standby roles, redo transport, redo apply, physical versus logical standby, protection modes, broker, switchover, failover, and monitoring lag for recovery objectives. Question 6. What is Oracle RAC, and what performance problems can occur in a RAC environment? RAC lets multiple instances mount the same database, giving availability and horizontal scale for suitable workloads. Nodes coordinate through the clusterware, shared storage, and cache fusion, which transfers blocks between instance buffer caches. Good candidates are services that can spread connections cleanly. Poorly designed hot blocks sequences, or excessive interconnect traffic can hurt performance. I would monitor global cache weights and design services for workload isolation. Make sure to cover shared database access, clusterware, cache fusion, interconnect traffic, services, load balancing, split brain prevention, availability benefits, and performance risks such as hot blocks. Question 7. A critical production query suddenly becomes slow. How would you troubleshoot it as an Oracle DBA? When a production query is slow, I first confirm the symptom with AWR, ASH, SQL Monitor, or vSQL. Then separate database time into CPU, I/O, locks, and waits. Next, I inspect the execution plan, cardinality estimates, bind peaking, stale statistics, and index access. I avoid random hints first. I test fixes with realistic data. The best tuning changes the root cause, not just one execution. In your answer, describe a methodical workflow. Confirm symptoms, inspect wait events, review execution plans, compare estimates to actuals, check statistics, binds, indexes, and validate fixes safely. Question 8. How do you decide whether an Oracle table needs an index, and what type of index would you choose? An index helps Oracle find rows without scanning the whole table, but it is not free. B-tree indexes fit high cardinality predicates, joins, and range scans. Bitmap indexes work well in warehouses with low cardinality columns and limited DML. Every index adds maintenance during inserts, updates, and deletes. I evaluate selectivity, clustering factor, access patterns, and whether a composite index matches the leading columns used by queries. Be sure to mention B-tree, bitmap, composite indexes, selectivity, clustering factor, leading column rules, DML overhead, execution plans, and when an index can actually hurt performance. Question 9. What is table partitioning in Oracle, and how does it improve manageability or performance? Partitioning breaks a large table or index into manageable segments while keeping one logical object. I use range partitioning for dates, list for categories, hash for even distribution, and composite when both access and manageability matter. Benefits include partition pruning, faster maintenance, and rolling data purges. It is not magic. Bad partition keys, global index maintenance, and skew can make operations harder than a normal table. While answering, focus on range, list, hash, and composite partitioning, partition pruning, maintenance operations, data purging, local versus global indexes, skew, and choosing a good partition key. Question 10. How would you investigate blocking sessions and deadlocks in Oracle? Oracle uses locks to protect data consistency, usually row-level TX locks for DML, and TM locks for table-level coordination. Blocking is normal when one session waits for another uncommitted change. A deadlock occurs when sessions wait on each other in a cycle. Oracle detects it and rolls back one statement. I investigate vsession, vlock, SQL text, and application transaction order, then shorten transactions or standardize update sequences. Make sure to cover row-level locking, TX and TM locks, blocking sessions, deadlock detection, common application causes, diagnostic views, and practical fixes like shorter transactions. Question 11. Explain tablespaces, datafiles, segments, extents, and blocks in Oracle Storage Management. A tablespace is the logical storage container. Datafiles are the physical files that store segments. Segments contain extents, and extents contain Oracle blocks. I separate application data, indexes, undo, and temporary workloads for manageability, not because it automatically improves performance. For space issues, I check auto-extend, free extents, temp file usage, and growth trends. Good DBAs manage capacity before users see Aura L1653 errors during peak load. In your answer, talk about logical versus physical storage, tablespaces, data files, segments, extents, blocks, auto-extend, temp files, undo tablespaces, capacity monitoring, and common space errors in production. Question 12. What is the difference between a CDB and a PDB in Oracle multitenant architecture? In Oracle multitenant, a CDB is the container database, and PDBs are pluggable databases hosted inside it. The RAC stores common metadata, while each PDB holds application schemas and local objects. This model simplifies consolidation, cloning, patching, and resource control. As a DBA, I watch common versus local users, service names, unplug and plug operations, and backup scope. It improves manageability but requires clear operational standards. Be sure to cover CDB, root container, seed PDB, pluggable databases, common and local users, services, cloning, unplug or plug operations, resource management, and backup implications. Question 13. What is Oracle ASM, and why is it commonly used for database storage? ASM is Oracle's volume manager and file system for database files. Instead of managing individual mount points, I create disk groups with redundancy and let ASM stripe and mirror extents across disks. It works well with RAC because all nodes can access shared storage consistently. Key operational tasks include monitoring disk group space, rebalance operations, failure groups, and allocation unit size. It reduces storage complexity, but planning still matters. While answering, focus on ASM disk groups, striping, mirroring, failure groups, redundancy levels, rebalancing, shared storage for RAC, monitoring free space, and why ASM simplifies administration. Question 14. How do optimizer statistics affect execution plans in Oracle? The optimizer chooses execution plans based on statistics, cost estimates, and available access paths. I read plans from the bottom up, checking join order, join methods, access predicates, estimated versus actual rows, and expensive operations like full scans or sorts. Stale or missing stats often cause bad cardinality estimates. I use DBMS stats, SQL monitor, and sometimes histograms. Hints are a last resort when plan stability cannot be achieved otherwise. Make sure to cover cost-based optimization, table and index statistics, cardinality estimates, execution plan reading, joins, access paths, histograms, DBMS stats, SQL monitor, and cautious hint usage. Question 15. How would you plan and execute Oracle patching or a database upgrade with minimal downtime? For patching, I start by identifying the current version, target RU, known conflicts, and application certification. I back up the database and Oracle homes, test the patch in lower environments, run OPatch checks, apply binaries, and run data patch for SQL changes. For upgrades, I use pre-upgrade checks and rehearse rollback. In RAC or DataGuard environments, rolling approaches can reduce downtime, but only with careful validation. In your answer, discuss OPatch, data patch, release updates, conflict checks, backups, test environments, rollback plans, pre-upgrade checks, downtime planning, RAC or DataGuard rolling options. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.